Alright guys, today's goal, the learner will understand how to select and draw conclusions from samples. Okay? A population is a group of people or objects that you want information about. When it is too difficult, time-consuming, or expensive to survey everyone in a population, information is gathered from a sample or subset of the population. Some methods for selecting samples are described below. So we need to read through these. We need to understand what they are, because it is way easier to do a sample than it is a population. So the first one here. In a self-selected sample, members of a population can volunteer to be in the sample. So a good example of this is oftentimes when you see people like set up outside of a grocery store or something, and they're like, hey, will you take this survey? Well, they select to take the survey. That's called self-selected. Okay? In a systematic sample, a rule is used to select members of a population, such as selecting every other position. Okay? So if you assigned like a classroom, the students a set of numbers, and you said every fourth person seated, that's systematic random, okay? In a convenience sample, easy to reach members of a population are selected, such as those in the first row. Okay? In a random sample, each member of a population has an equal chance of being selected. So think about when my random name generator is up there, and I'm randomly selecting you. You all have the equal chance because every name is in there. Okay? Now, here's a big thing that happens. Bias in sampling. In order to draw accurate conclusions about a population from a sample, you should select an unbiased sample. An unbiased sample is a representative of the population you want information about. A sample that has overrepresents and underrepresents part of the population is a biased sample. So think about restaurants that do surveys right outside their restaurant, where it's like, do you like going to this restaurant? Things like that. Well, they're already at the restaurant, so they must like it, or they must have known about it. So that produces a biased sample. Okay? So let's take a look at some examples here. A computer science teacher wants to know if students would like the morning announcements posted on the school's website. He surveys students in one of his computer science classes. Identify the type of sample described and tell whether the sample is biased. So with this one, we need to give what we're thinking and why. So it says a computer science teacher, and he does a computer science class. So to me, that's the definition of the convenience sample. Now this is where you have to think, is it biased or unbiased? I would say it's biased, because he is asking about posting something on a website from a computer class. So, because posting website material in a computer class. Because see, if he just had random students, maybe they didn't like it. But of course, the computer people are going to want to post it on the internet. Okay? Alright, so let's look at this one. You are a member of a prom committee. You want to poll members of a senior class to find out where they want to hold the prom. There are 324 students in the senior class. Describe 2 different methods for selecting a random sample of 40 seniors. Okay, so one way. Let's see, you could assign all students an integer So like the first student would be 1, the second student would be 2, the third student would be 3, all the way up to 324. And randomly select 40 students. That would be a random sample. Okay. Another way you could do it would be a systematic, where you still assign all the students an integer, but instead of randomly selecting 40, you say, I will select, let's see, every 5th number until 40 are selected. So there's the systematic sample. Or you could do convenience sample and set up a table and the first 40 seniors that go there to fill it out. Alright, so okay, so there's different methods. Alright, so sample size. When conducting a survey, you need to make the size of your sample large enough so that it accurately represents the population. As the sample size increases, the margin of error decreases. What that means is the closer to the complete population you get, the less error of the response there is. So the margin of error gives a limit as to how much responses of the sample would differ from the response of the population. For example, if 40% of the people in a poll prefer candidate A, and the margin of error is plus or minus 4%, then it is likely between 36 and 44% of the entire population could prefer candidate A. Okay, so how do we calculate the margin of error? You do plus or minus 1 divided by the square root of the sample size. N is the sample size, okay? And then you get your probability and you do minus that and plus that. That's why there's that plus or minus. So let's look. It says in a survey of 1,202 people, 11% said they use the internet or email more than 10 hours per week. What is the margin of error for the survey? Okay. So the margin of error, that's this. So they want the margin of error first. So the margin of error equals plus or minus 1 divided by, what was our sample size? Square root of 1,202. So square root 1,202. You get approximately 35%. Oh wait, that's just the square root, not 1 divided by that. I was going to say that's huge. Approximately 0.03. That's our margin of error. Okay. It says how many people would need to be surveyed to reduce the margin of error to 2%. So we're at 3%. So, well, let's see. So 2% as a decimal, though, is 0.02, and we want that to equal this. So first thing I got to do, multiply by the square root of n. So you get 0.02 square root n equals 1. Then we have to divide. So 1 divided by 0.02, you get Square root of n equals 50. Square both sides. You get the number equals 2,500 people. Okay. Now if we go back to this first survey with the margin of error of 3%, and we look, it's at 11% said they use the internet, or so really what with this you would say 8% to 14%, because 11 minus 3 is 8, 11 plus 3, 14. Use the internet that much. Okay? Alright, well, see you in class.